Okay, hello there. I hope everybody could still listen to me. So today we're going to try answering chemistry paper 2. I obtained this paper from the Google. It's one of the trial for 2021. So I'm just going to make this session very short. Perhaps I'm just going to cover only 3 questions because due to the fact that I like the time, and it will be much more better if we could break it into smaller sessions. So without wasting any more time, let's try answering this. So what is the meaning of isotope? So when you read the question, when it is meaning, you should know that it is a question that requires you to memorize. There are certain topics in chemistry, both in Form 4 and Form 5, that requires memorizing. So you may be you may feel like, oh, it's chemistry. Why do I even need to memorize facts? But this is the irony of chemistry, where our syllabus requires a lot of memorizing. So for meaning, of isotope, we start any types of definition by categorizing what we are referring to. So for isotope, we could call it as isotopes are of the same element which have same proton number but different nucleon. I'm sorry, different nucleon number. So in chemistry, we don't actually have a term as neutron number. We only have nucleon number, which refers to the entire collectively entire number of protons and number of neutrons in the nucleus of an atom. So this is the definition for isotope. Isotopes are atoms of the same element which have same proton number but different nucleon number. Or we could also say that isotopes are, let me just copy this back. I don't want to type everything again. So copy and paste. Okay, let's better. Isotopes are atoms of the same. Oh, you can't see this now. See, these are the problems that you may face when using notes, OneNote, to be honest. So hopefully you could still see a part of it. Let me try fixing this quickly. Okay. Isotopes are atoms of the same element which have same proton number. Oh, no. Which have same number of protons, different number of neutron. that is the definition for isotope. Isotopes are atoms of the same element which have same proton number but different nucleon number. Or you could also say that isotopes are atoms of the same element which have same number of protons but different number of neutrons. So technically, both of these answers are almost similar, but if you look closely, so the term we use for the top one here, we are calling it, the term we are using is proton number and nucleon number. But for the second answer, we are using the term number of proton and number of neutrons. So the difference is the terms. So why it is different from one another, why you can't mix it up? Okay, first of all, you can't say different neutron number, which is completely wrong because there's no such uh, term as neutron number. But nuclear number refers to the number of protons and neutrons in an atom in a nucleus of an atom. And then we have these same number of proton but different number of neutron. So you could address the neutrons different number of neutrons. So this is correct. The answer scheme itself will have the second answer. And another thing that I would like to emphasize here, although this may seem like an easy question, you have to be very careful because you can't mix up these terms. So what do I mean by mixing up these terms? So for instance, you are answering isotopes are atoms of the same element which have same proton number but different number of neutrons. Now, if you answer like that, your answer is incorrect. Although it brings the same meaning, you can't mix up terms. So when we're using proton number, you must use nucleon number as your term to address the number of neutrons. And when you're using number of protons, you must use number of neutrons to address the number of neutrons in the nucleus. So I hope that gives a better clarification. If you still find it kind of hard, you can repeat this part until you could finally understand. So let's just move on to this next question. So state the name of all subatomic particles inside the nucleus. So let me highlight this as well. So they are asking for subatomic particles. So in chemistry, we have learned only 3 subatomic particles. So, but here is the trick. We have 3 subatomic particles, which are proton, neutron, and electron. However, if you could look at this highlighted part, I highlighted inside the nucleus. So when we're talking about inside the nucleus is the center of an atom. It could call it the center of an atom. It may be not, because if you go deeper into quantum physics, you might not, you would have a different understanding towards this. Okay, so we'll just assume it's the center of an atom where there is proton and neutrons located inside of it. So that is a nucleus. And how about this part? Isn't this circle containing this electron not part of a nucleus? Yes, it's not part of a nucleus. And what you call this circle? This is a shell. Shell refers to regions where electrons could possibly be. We can't say for sure electrons orbit the entire atom here, you could just assume the electrons could exist anywhere around this region simultaneously. So there's also a bit more about quantum, the more you know now. So anyway, if we are focusing back to this question, state all subatomic particles inside the nucleus. So we only have proton and neutrons here, both here and here. This one, since they are referring to the nucleus, it is the definition itself is a region where a part where protons and neutrons are found inside of it. So it's definitely the subatomic particles would be protons and neutrons. Okay, next, name subatomic particle that is negatively charged. Okay, so this is a very easy question. So technically, the proton has a positive charge. Please pardon my bad handwriting. It's kind of hard using a mouse. And neutron does not have any charge. It's the name itself suggests that the charge is neutral. It does not have any particular charge. And for electron, we have a negative charge. Okay, so particle that is negatively charged will be electron. Okay, next. Do the three hydrogen atom in diagram 1 have the same chemical properties? Explain your answer. Okay, so another keyword here. Same chemical properties. So in chemistry, I believe if you have learned periodic table of elements, you would know that the valence shell of an atom, the valence shell is the outermost shell containing electrons. So this only this valence shell will ever determine whether or not it have the same chemical properties or not. So how do you determine? For instance, if you notice, all these three isotopes of hydrogen have the same number of electrons in its outermost shell, which is 1. So technically, when you have same number of electrons in the valence shell, automatically you would have the same chemical properties for all of the isotopes, because when you learn chemical bond, you will know that uh, the the ions of hydrogen will will not have a electron. They have lost the electron and they achieve stable duplet. Wait, let me think for a while. Okay, I'm sorry. For hydrogen ion is basically H plus, right? Hydrogen ion is H plus. Okay, so when we have H plus, they all have lost an electron. They all lose, they all donate one electron to form a bond with another atom. Regardless how many hydrogen atom is involved, each of them will release one electron to donate so that they could form either an ionic bond, or they could also share with one another. Two hydrogen atoms could share their electrons, each contributing one, so they would have two electrons in shells of each of atoms, which means they would have achieved stable duplet electron arrangement. So back to the question. Since we have noticed that each of the isotopes have the same number of electrons in their valence shell, so we know for sure that they yes, they do have the same. Wait, something's wrong again. I'm really sorry. Ah, okay. Do these three hydrogen atoms have the same chemical properties? Yes. Why? Because they have the same number of electrons in their valence shell. Yes. Of the isotopes have the same number of electrons, number of valence electrons. So you could call them the valence electron. Valence refers to the outermost, anything of the outermost part of an atom. So there's two terms. Valence electron is the electron located in the outermost shell, and outermost shell is also called valence shell. So students, you guys could use two of these terms to address this specific part of an atom. Okay, so that is for question one. So state the type of gas particles in gas A. So let's highlight this. We're talking about gas A, and what they are asking is particles in gas A. So if you observe, you could see that there is sharing of electrons happening over here and here and here. There's three hydrogen atoms and one nitrogen atom. So as a chemistry student, you should know that this is ammonia gas. So um, I think throughout your way studying chemistry, you will eventually know that this is an ammonia gas as soon as you see it. So we're talking about gas A. So I believe this is basic of Form 4, identifying gas, molecules, and ion. I'm sorry, identifying ions and molecules and atom. There's only three particles. There's ion, atom, and molecule. So technically, when you refer a gas, although we do look at these individual atoms, when we're talking about gas, we are referring to the whole, the entire, the entire part of this. Okay, so when we're referring this as a whole, this is a molecule, because they have already formed a bond with one another, including atoms of different elements. They have formed bond together, and that means they are in the state of molecules. Alright, what is the purpose of chemical bond? So this is chemistry form for chapter 5 about chemical bond. So what is the purpose? This is also a basic question. The purpose of a chemical bond formation would be to achieve stable duplet or octet electron arrangements. Might even want to add on a bit. So how do you achieve the stable duplet or octet electron arrangement? By donating, receiving, or sharing electrons with another atom. Another particle to be more accurate, but you don't really have to uh, need this by donating, receiving, or sharing electron. I'm just adding it because the answer scheme changes every year. The answer scheme for this particular question is just under this: to achieve stable duplet or octet electron arrangement. So they do not have by donating, receiving, or sharing electrons, but as a student it is always a better choice for you to give answer that is complete in its structure, complete in what you're trying to explain. So I'm just gonna leave it to be like this. We're gonna look at the next question. State the type of chemical bond in gas A. So there are multiple types of chemical bond that we have learned. One is ionic bond, then we have covalent bond, and we also have dative bond and metallic bond, if I'm not mistaken. Alright, it is these four. So one of the two main bonds we learn is ionic bond and covalent bond. So it is extremely crucial for you to be able to differentiate between ionic bond and covalent bond. So how do you spot the difference? It is right where I have highlighted. When you see two shells containing electron overlapping with each other, and you don't have this. Usually when you have a ionic bond, this is how it should be. So you will have one part with plus and another part with another atom. Let's just label this as X. And then yeah, you will have square bracket, and you will have two opposite charges. So this is what makes ionic bond different from covalent bond. Covalent bond is where the atoms will share electrons with another atom. So this is what we call sharing. They're not actually losing their electron. So before this I said that hydrogen usually form bond by releasing electron, and another atom will receive the electron for it to become negatively charged, and hydrogen which have lost its electron become positively charged, and the strong electrostatic forces between one another will form a bond between these two uh, particles, which are now known as ions. So how about this? This is what you call sharing. You cannot see that they have lost an electron. You don't have this charge or anything. They have just sharing their electrons with another atom. which is now there are 3 hydrogen atoms. They are sharing one pair. So we call this as 3 single covalent bond. Let me write it down for you. Right. So this is where 3 single covalent bond. Okay. So when you have to able to see the difference as well. So we call it single covalent bond because we are only sharing one pair of electron. And in case we are sharing 2 pair of electrons, we call it double covalent bond. And the number of single covalent bond happening over here is 3. So it is 3 single covalent bond. Okay, I hope that explains a bit. So state the type of chemical bond in gas A. Okay, another thing is that it is because it's a gas. And usually gas are formed through covalent bond, most of the gases. There may be some gases which are um, formed through another type of bond, but usually it is just a covalent bond. Okay, so now this will be covalent bond. Okay, explain how the chemical bond is formed. Okay, this is where you usually this type of question have 3 marks, but this is only 2 marks, so it's a safer option, to be honest. It's much better. How the chemical bond is formed. So we could explain what are the atoms involved and how many pairs of electrons that are being shared, and each of the atom contribute how many electrons. So that are the points that you have to explain. So okay, wait, I lost my okay. So 3 hydrogen atoms, uh, a pair of electron, a pair of electrons, of the. So this type of question is kind of tricky because you have to be very specific. Each of these 3 hydrogen atoms share a pair of electrons with 1 nitrogen atom. Of the 3 hydrogen atoms, give you 1 electron for sharing, while nitrogen atom contributes 1 electron for sharing with each of the 3 hydrogen atoms. Okay. So you could also add finally what is the product form. So this question is actually a shorter version of the essay question. There's a high possibility that this question is tested in the section B or C of paper 2, which is where you have to be explaining this entire question for about 5 to 6 marks. Usually it's 5 marks. You have 5 points that you have to explain, and each sentence will bring 1 mark. So you'll be writing 5 points if it was in essay. So this is 2 marks. So it shouldn't be a problem. Okay, let's do this real quick. What is represented by the number in number 17 in diagram 3? So okay, so for diagram 3, these numbers. So this is also a question from periodic table of elements chapter 4 form 4. So when you look at this, you know that this represents two different things. This is the nucleon number, and this is the proton number. So if you have already learned this, you would have known. So this ain't a big hard question. What is represented by number 17? It is the proton number. State the period of element X. Okay, whenever you see this standard electron representation, you should straight away write its electron arrangement. So you should know that the number of proton is same with number of electrons for an atom, and I'm emphasizing for an atom, not ion, not any other particles. For an atom, the number of proton is same with the number of electrons. So the electron configuration should be 2 dot A. Okay, I'm really messing this up. Okay, I'm having trouble using my keyboard right now. My mouse, it's very not helpful. Okay, 2.8.7. So sum all of this up, you will get 17. So that is the electron arrangement. State the period of element X. So you should know that the last number, the valence electron, determines which group the atom is, the element of the atom is, and the number of shells. Each of these are shells. Okay, so this is the first shell. The first shell is always 2. The second shell and the third shell must contain up until 8 electrons. There's the maximum. Each of the shells have maximum number of electrons which they can accommodate. The first shell is just 2, and the next 2 is 8. So for the last shell, we don't have enough one more electron. So when it actually receives one more electron, it will achieve stable octet electron arrangement. Okay, so as a chemistry student, you should know that 2.8.7 is 2.8.7 is chlorine. Alright, so the period is the number of shells of the atom. So this is just this right number, or you could spell it out. Either one goes well. Okay, X reacts with hot iron wool to form brown solid. So as I've said before, X is 2.8.7, it is chlorine. Okay, you could actually instead of using X, you could just write Cl, chlorine. chlorine. But yeah, I really recommend for you to use the periodic table of element which is provided in the last or the first page of your paper. If it is standardized test, maybe the periodic table of element will not be provided, but if it is a much more official test by the government such as SPM itself, the periodic table of element will be provided, and it is wise for you. I really recommend for you to check out this thing. However, uh, if you're if you really have done enough revision, you would already know that this is chlorine. Anyway, write the chemical equation means we are looking at iron wool. Iron is Fe and it forms a brown solid. Okay, so this is another kind of like trap question. It's not exactly trap question. I mean, it's a question that you have to give particular attention. When you say brown solid, it means it is Fe3 plus that has formed. Fe3 plus is Fe, iron, is a transition element. Fe2 plus is green in color and Fe3 plus is brown in color. And when we look at brown solid, it means Fe3 plus have formed. So when we are writing the chemical equation, first of all, you write the symbols for each of these. First, Fe. Okay, why is it so huge? I thought I reduced the size of it. Okay. Okay, Fe plus, wait. You can either write Cl or X, up to you. I'm gonna just write Cl because when I actually see it Cl, I know it exists in the gas state when in room temperature. So I can just write Fe plus Cl2. This is very important because the halogen, the group 17, uh, they have different states for each groups. I mean each period. So brown. Hey guys, I like this is just as far it goes. My laptop just shut down. But however, I no problem. I did promise you up until we will continue on this for your time. I think, yeah. Thank you so much. So for the question just now, I will cover it. Unfortunately, my laptop died out, but it's okay. Thank you so much. Bye.